So let's look at the two types of covalent bonding. We have what we call nonpolar covalent. This is where both atoms have the same or very, very close to being the same electronegativities. So we pretty much, in a nonpolar covalent bond, we have equal sharing. All right. When we talk about the word polar in chemistry, what we're talking about is a separation of charge. We would have one end of our bond would be more negative, one end of our bond would be more positive. And the other thing to remember is that it's really the movement of the electrons. Where the electrons have the highest density, that creates our negative side of the bond. Where the electrons are less dense, that creates a more positive side of the bond. So here we would have chlorine to chlorine, so we would have equal electronegativities, and if this were our electron cloud that's formed from the bond, you'd see our electron densities would be fairly even across both atoms. Polar covalent, we have uneven sharing, and so you can see here, hydrogen and chlorine, we have a little less electron density here around the hydrogen, a little more electron density around the chlorine. Chlorine has a higher electronegativity, so it attracts the electrons more strongly in the bond. All right, so how does this affect the properties, the types of bonding? All right, at this point, you may want to get out the bonding comparison chart because the rest of this discussion is going to help you fill in that chart. All right, so let's look at their structure. The structure of metallics, they are flexible and crystalline. Okay, by the word crystalline, normally people think of like brittle crystals, and so you're going, what does that mean with a metal? Well, crystalline really means we have a repeating arrangement of these atoms, an ordered arrangement. Okay, rather than just random arrangement. So it has an ordered arrangement and it's flexible. And if you think about it, that sea of electrons, all right, if my bond is from this mobile sea of electrons moving around in between the positive cations, that is going to create a flexible bond, a bond that can kind of go with the flow. Hence, we have malleability in metals, we have ductility in metals. All because of the bond. Now here is ionic crystals like sodium chloride, for example, table salt, and we have a more rigid or brittle but still crystalline arrangement of the ions. Covalent molecules, however, form molecules. And so at this point in your chemistry career, you should start to make a distinction. All right? Let me go back to here in the ionic structure here. As you'll notice, we have just this infinite array of positive ions, positive sodium attracted to negative chlorines. And this arrangement just kind of goes on forever, until you reach the edges of the crystal. Well, there's no way to determine, what sodium belongs to what chlorine, because they don't. They're all kind of inter-attracted to each other in this big array. All right, so the word molecule really does not apply to ionic substances. It tends to be used kind of generically, but you should start making a distinction. Usually when we talk about ionic compounds, we'll talk about formula units, and that would be a formula unit for this particular crystal would be 1 sodium and 1 chlorine. Whereas when we're talking about covalently bonded substance, the word molecule really does apply because we have, in this case of water, specific hydrogen atoms attached to a specific oxygen atom. It makes a unit that stays together. And so we can use the word molecule, and that's typically what we mean when we use the word molecule, is a covalently bonded substance, and sometimes you'll see them referred to as molecular substances. Melting points. Metallic substances tend to have high melting points. Not always true. The group 1 metals you'll see have unusually low melting points for metals, and they do tend to be solids at room temperature, with the exception of some metals like mercury, for example. Ionic substances tend to have high melting points, tend to be solids at room temperature, whereas covalent substances tend to have relatively low melting points as compared to the other types of bonding, and they can be solids, liquids, or gases at room temperature. Solubility. Solubility is, will it dissolve in water? Okay, we're talking about aqueous solubility here. Metallic bonds, no. Ionic bonds, yes. For covalent substances, it depends. If it's polar covalent, it will dissolve in water. Nonpolar covalent will not. Again, as we go further through the semester, we're going to look at why this happens, why these properties are what they are. Conductivity. Metallic substances, yes, they are conductive. Ionic substances will conduct electricity, but only when they're molten or when they're dissolved in water. Okay, that's because we need to have free moving ions to carry the charge. And so in a solid ionic substances, those ions are not able to move. But if it's molten or dissolved in water, then you have movement of the ions to carry the charge. Covalent substances, no, do not conduct electricity.